In this question, he is saying that consider sunlight incident on a pinhole of width 1000 angstrom. The image of the pinhole seen on the screen shall be. So what we have to consider a pinhole. So this is the wall of the pinhole and this is the pinhole, and sunlight is entering through this pinhole. So when we say the sunlight, this means plane wavefront. Plane wavefront is incidenting on this slit arrangement, and also the size of the slit. The size of the slit, let this size of slit is D, and it is given equal to 10 raised to the power 3 angstrom. Now the sunlight is comprised of the wavelength from 4000 angstrom to 7000 angstrom corresponding to the optical spectrum. So as the size of the slit is less than the wavelength of the incidenting radiation, so definitely diffraction will take place. So when the sunlight passes through this pinhole, diffraction definitely takes place. So diffraction takes place means there will be the bending of light. So when the bending of light is there, and we know that the angular spread or the angle through which the light will get diffracted is directly proportional to lambda. So more is the wavelength, more is the diffraction, and we know that the sunlight comprised of these 7 colors. So the wavelength is increasing in this order. So more is the wavelength, more is the spread. So if we look at this diffraction pattern, which is approximately look like this, not exactly, but you can imagine the same situation, that the diffraction pattern is approximately like this. So here we have a white central spot, a sharp white central spot, because this is the central maxima of the diffraction, and all the colors have constructive interference in this central region, and this central region is of different geometry than that of the size of the slit. So the central maxima or the central spot is a white spot, and outside this white spot you can see here in this region, you can see it starts from blue and it ends up at red. So as we move away from this blue to red, so or you can say that as the wavelength is increasing, so does the angular spread. So from this information and from this observation, we can say that the pinhole have a different image from the geometrical image, means the size or this diffraction pattern is different from the pinhole geometry. Clear? Means the light that is falling on the screen is of different size than the size of the pinhole. So from here we can say that option B is correct, and also option D is correct, in which we have diffused color region around a sharp central white spot. So here we have a sharp white central spot and we have a diffused colored regions around the sharp central white spot. So what we have discussed here is on the basis, and we have assumed that this diffraction is Fresnel diffraction. We have explained this on the basis of Fresnel diffraction, assuming that the arrangement is satisfying this Fresnel diffraction conditions.